show that any positive odd integer, keyword here, odd integer, integer 2 is a keyword, is of the form 6q plus 1, 6q plus 3 and 6q plus 5. So let's first understand this. What does it mean? So to help us with that, I'll open our coding. Okay, so Euclid division lemma, divisibility. So I'll start the number with 650 till 700. Let me make it as 600 to 740, right? And the divisor is 6. Okay, I put the divisor 6. So let's look at the output, right? And that's too much. Let me cancel it out. Oh, this is 7. Okay, 640, because there was too congested, right? That's the right answer, but too congested. Actually, I can zoom in, but okay, let me do that only. Execute. So right, I zoomed in. So you can clearly see I have a bunch of numbers which are quite congested. Actually, again, I'm not happy. Let me make it as 640 itself. Okay, better now. So let us copy this and try to examine. So what we're looking at is bunch of numbers starting from 600 to 640. And we're looking at, the heading will be divisibility of numbers. Actually, not divisibility, reminder now. Okay, I can't do that. Let me paste it again. Yeah, reminder. Reminder on dividing with 6, right? So now 600 when divided with 6 will get you 0. 601 when divided with 6 will get you 1, and this will give you 2, 3, 4 and 5, so on and so forth. So the first thing that we can observe here is it is not crossing the benchmark 6 that we already have seen in the first set of videos. It will never cross the one which is dividing the bunch of numbers. Now the question talks about that if we consider the odd numbers, so we have odd number here, 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 right? Alternatively, we have odd numbers. So what they're telling is you choose any odd number, it will be either represented by 6q plus 1, is it not? So let me choose an odd number, 617. So when divided with 6, it will give you a remainder of 5. So it is represented by 6q plus 5. Another number, 619, has a remainder of 1. So we have 6q plus 1. This one, 621, we have a remainder of 3. Good. 623, we have a remainder of 5. So clearly we can see that you choose any odd number, you will end up with either a remainder of 1. So all of these numbers will be an odd number. This also will represent an odd number. This also will represent only odd number and nothing else. Okay, all the odd numbers will be within this line with this particular respective reminders. Okay, that's what the question talks about. But this is bunch of numbers, not the entire set of integers, positive integers. So you have to show for the entire range of it. So to do that, what to do? Well, we'll make use of our Euclid division lemma. So start with as per Euclid division lemma, right? If A and B represents all positive integers, right? We have A is equal to B into Q plus R, where R is greater than or equal to 0 but always lesser than B, where Q and R are unique positive integers, right? You can also write it as int. Okay, instead of integers, let's start writing it as int, because it is helpful in your knowing this is helpful in your coding. See, int, I use the word int, it's a keyword over here in Python. It means integers. So what does it do? I'm not going to talk about that. So using this as a word over here will help you. I just want you guys to know that. Of course, if your teachers have issues with this, then don't do it. If not, it's okay to use. Now, what do we have to substitute? We have to substitute in place of B, we have to substitute 6, right? Is it not? So we have A is equal to 6Q plus R, where R is greater than or equal to 0 but lesser than 6, right? This is what we have to know. Next, this implies a remainder should be equal to 0 or 1, 2, 3, 4 and 5. The reminders can be any one of this. So now we're looking at case. Different cases. We will start off with case when the remainder is 0. But before that, I would like to do one thing. This is a trick which I use to make the calculation a bit easy. 6Q, I can always write it as 2 into 3Q plus R, right? And I can rewrite this as 2M plus R, where M is equal to 3Q. Okay, I am rewriting the given equation. Why? I'll show it to you. It will reduce the calculation. So now when the remainder is 0, we have A is equal to 2M plus 0. 2 into something is an even number. Now case when the remainder is 1. So we have A is equal to 2M plus 1, which is an odd number, right? All you did was we wrote the Euclid division lemma statement, and we wrote that, okay, these are the possible remainders if we divide with 6. And now we are taking each case and showing that, okay, this represents even number, this represents odd number. So we are just doing that. Case when the remainder is 2, we have A is equal to 2M plus 2. 2 is common. You have M plus 1, which is nothing but an even number, right? Then we have case where R is equal to 3. So we have A is equal to 2M plus 3, which I'll rewrite it as 2M plus 2 plus 1. Quite simple. Taking 2 common, so that will give us 2 times of M plus 1 plus 1. So this is even plus 1, which will make it an odd number. Then we have case when the remainder is 4, right? So you have A is equal to 2M plus 4. Here I'll take a common of 2. We'll get M plus 2. So 2 into anything is an even number, right? And we have case when R is equal to 5. So we can rewrite this as 2M plus 5, which is nothing but 2M plus 4 plus 1, right? We can rearrange it and write it as this. So taking 2 common, we have 2 times of M plus 2 plus 1, which is an odd number. So if you observe carefully, the conclusion is that we have odd here, here and here being represented by, right, m is nothing but your 3q, so this is 6m plus 1, and this is also, right, we started with this 6q plus 3 and 6q plus 5, right. All the odd numbers have been represented by this 3 set of expressions and nowhere else. Okay, that's what we wanted to prove. We wanted to prove that exclusively this particular set of numbers will represent all the odd numbers. Okay, that was the whole idea. So to summarize, if you have bunch of numbers, or all of this is your all the possible integer numbers. So if I classify them into different groups, right, wherein if the on dividing with 6, remainder will be 0, 1, 2, 3, 4, 5, right, remainder will be this many, and this will be even, this will be odd, this is even, and this will be odd, this is even, and this is odd. This is what we showed, and all the possible odd numbers have been represented by this many group and nothing else. That was the question, and that's your answer as well, right?
Please enroll to our program at chalkpieceacademy.com, wherein we'll be teaching you a lot more tricks for faster simplification calculation, DIY projects. We'll code with Python, we'll work with Arduino Uno. There are a lot more magic tricks and the physics behind it. They are printable materials which will help you recap and understand things better. We'll have live revision and doubt session 2 months before your term exams. It's very cost effective. There would be no ads or any kind of distractions, and we have a dedicated app to help you guys with this.